Today we're going to be talking about aluminum and its properties and its uses. Aluminum is an element that is a silvery white metal that is lightweight and is found mostly in the Earth's crust. Pure aluminum is weak and soft, but when combining it with another element makes it an alloy. For example, mixing a small amount of iron and silicon makes it strong. Aluminum has an oxide that forms on its surface, giving aluminum its corrosion resistance. According to this metal supplier, there are 7 grades of aluminum. The first grade is going to be 99% pure aluminum, which has high electrical and thermal conductivity. The second grade contains copper and has high strength to weight ratio with low corrosion resistance. The third contains manganese and has moderate strength with good workability. The fourth grade contains silicon and has a lower melting point with high wear resistance. The fifth grade contains magnesium, and that yields moderate to high strength with good weldability. The sixth contains silicon and magnesium, which gives it good corrosion resistance, medium strength with a good weldability. The seventh grade contains zinc and yields moderate to very high strength. Some examples of grades and their filler rods would be 6061, which contains magnesium and silicon and can be welded with ER4043 or ER5356. 7075, which contains zinc, magnesium, chromium, and copper, is hard to weld and only can be done using resistance welding or spot welding. 5052 can be welded with either ER4043 or ER5356, but 5356 is a harder material which is likely to crack compared to 4043, which is more ductile. 3003 can be welded with 4043 or 5356 as well, and 1050, which is mostly pure aluminum, can only be welded with ER4043 as well. Aluminum is widely used in a lot of products. 3003 is used for pressure vessels and piping, as shown in 5052 is used on fencing and small boats, while 6061 is used for ramps, walkways, and stair treads. 7075 is used in aerospace applications and used to make missiles or spacecrafts. The reason aluminum takes more amperage than steel because there's an oxide layer that melts at around 3600 degrees, but the aluminum underneath that oxide layer only melts at around 1200, so the extra amps is to break through that oxide layer and be able to get to the base metal. Aluminum cross-contamination is when a shop prepares and welds on both steel and aluminum. Iron particles are launched in the air and can settle as dust. Using the wrong abrasive or an abrasive that has been used on steel to prevent this, the best thing to do is to store the materials in a separate area and to keep the aluminum abrasives in an airtight container. If contamination does happen, the use of solvents and abrasives are a good way of removing contamination. In this image right here, you can see a contamination starting to form around the steel inserts in the holes in the anodized aluminum base plate. Abrasives used for aluminum are going to be coated or bonded to prevent loading, which happens when the base material heats up and sticks to the grains of the abrasive. You also want to use a stainless steel brush so you're not adding iron particles while brushing, because you don't want to add any iron particles from a normal steel brush. Here are the pros and cons to aluminum. Some of the pros are that it's lightweight, high strength to weight ratio, and 100% recyclable. It is corrosion resistant and easily colored through the anodizing process. Cons to aluminum would be that it's more difficult to weld than steel, costs more to produce aluminum, only some grades can be welded, aluminum cookwork can only last a limited time due to its chemical properties, and it's not as corrosion resistant and strong as stainless, but it's still cheaper. Aluminum electrolysis is used to extract aluminum from its ore bauxite. It uses large amount of energy and electricity to break it down to aluminum oxide. Here's a short video on electrolysis explaining it further.
And dissolved in molten cryolite, a less common ore with a lower melting point. This saves costs as aluminium oxide has a melting point of over 2000 degrees Celsius. The electrodes used are made of graphite, carbon, which is a very good conductor of electricity. Aluminium forms on the negative electrode and oxygen migrates to the positive electrode.